Hey folks, now we're going to look at the last two types of problems that are problem types 3 and 4 for projectile motion. And this particular problem, instead of either just dropping it off the building or throwing it upwards, we're now going to throw the object downwards and time it. So we're at a different building and we suspend an object over the edge of the building, throw it downward, so it has an initial vertical velocity of -6 meters per second. It's very important because again, we're throwing it down, it must be a negative quantity. Gravity is also negative, 10 meters per second squared. And say we time it, and it takes, say, 2.3 seconds for the object to hit the ground. Now, if I'm looking for the distance, the vertical distance, or the height of the building, again, we have a vertical velocity, initial velocity, we have acceleration, we have time. We're going to use that length here, distance formula. That is the v sub ot plus 1/2 at squared. So, we have our initial velocity of -6 meters per second times our time of 2.3 seconds plus 1/2 gravity, which is -10 meters per second squared, times our time of 2.3 seconds squared. So, again, type it all in one line on your calculator. So much easier when you do it that way. So we have -6 times 2.3 plus 0.5 times our -10 times 2.3 squared gives us -40.25 meters. And again, just relating to how we did with the previous problems, draw your XY axis. That means that the object landed 40.25 meters below where it started. So that's problem type 3, where we're throwing it down. Lastly, we're going to look at problem type 4, which is projecting the object horizontally off the roof, or say it was rolling or traveling and then just fell and went off the roof. So we have an initial horizontal velocity of 7 meters per second. And we have a vertical acceleration of -10 meters per second squared. And we time it, and it takes 9 seconds. So I'm actually asked for two different distances here. One, I'm going to ask for the height of the building, like we've been doing. I'm also going to ask for how far away the object lands from the base of the building. Previous three examples, we're dropping or throwing up or down. It's only traveling vertically. Disregarding wind resistance or anything like that, it landed vertically exactly where it was when we released it. Now it's going to be a little different. It's going both horizontally and vertically at the same time. So, first we're looking at calculating the vertical height, or the vertical distance here. So vertically speaking, we have an acceleration time, of course. A lot of people think we have a vertical initial velocity. This isn't. This 7 meters per second is purely horizontal. It has no bearing whatsoever on the vertical drop. So as it travels off, and all of a sudden there's no table underneath it, it falls. There is no force put on it to make it go either up or down. So vertically, it's starting from rest. So the first item, we're going to look at the 1/2 at squared. I'm going to use the subscript of t sub b here to note that's our vertical distance we're looking for. So we have our 1/2 gravity, which is -10 meters per second squared, times our time of 9 seconds squared. And again, type it in your calculator. So we have 0.5 times -10 times 9 squared. We end up with a vertical distance of -405 meters. It's a pretty tall building. So that tells us how high the building is. Because again, the object landed 405 meters below where it started. So now we have to look at how far away it landed from the base of the building. So now we're looking at the horizontal distance. Now horizontally speaking, we know it's traveling 7 meters per second. And since I don't give you that it's accelerating, we can assume it's a constant 7 meters per second. So we have a constant velocity. And as soon as we had a constant velocity, think back to your 3 different distance formulas we talked about earlier. That will be your first formula, which is simply your distance is velocity times time. And now we're looking for that horizontal distance. So, in this case, we have our horizontal velocity of 7 meters per second, times our time of 9 seconds. Notice we're not using gravity here, because gravity's vertical pull has no bearing on a horizontal motion. So simply 7 times 9, which is 63. Looks like a negative, but it's not. It's 63 meters. So when I ask how far away from the base of the building does the object land, we can say it lands 63 meters out. So that's really looking at now both your horizontal and your vertical motion in one motion with two different distances. And that wraps up the types of problems you're going to be seeing.